For our last example in section 1.1, we're choosing the sequence an is equal to 3 plus 3n all over n for all natural numbers n. Notice I wrote the sequence slightly differently that time. We want to know if it converges or diverges. And remember, if it converges, we have to know what the limit is. We have to know what it converges to. So let's just note that this sequence is equal to, let's write out the first several terms and see if we can see what's happening. When a is a 1, we get 3 plus 3 over 1, we get 6. When a is a 2, we get 3 plus 6, 9 over 2. I'll write it like 4.5. For 3, I get 3 plus 9, which is 12. 12 over 3 is a 4. You may have ideas where this sequence is going, but let's continue. 1, 2, 3. Now we're on 4. 3 plus 12. 3 plus 12 is 15. 15 over 4 is 3 and 3/4. Let's do one more. So for 5, 3 plus 15 is 18. 18 over 5. 18 over 5 is 3 and 3/5. All right, so we've got a 6. We've got 4.5. We've got 4. We've got a 3.75, and we've got a 3.6. All right, let's jump way ahead. N equals, let's just say A100. That would be 3 plus 300 over 100. 303 over 100. That looks to be 3.01. Oh no, goodness. 3.03, right? Anyways, it's very, very close to 3. And it turns out that the limit is 3. This sequence converges to the number 3. All right, so now let's show that that's actually true. So we're going to show that this converges to 3. Well, as always, we need to say let epsilon be given every time we're trying to prove a sequence converges to its limit. And I'll kind of tell the story about what we have to do now. We must find the capital N in the natural numbers such that an minus a. So an is, well, I'll just write it like an for now. Whenever little n is bigger than capital N. That's what we need to find. But let's make a note here. We're going to do some algebra here that's going to make our lives very simple. And we'll be done here in just a couple minutes. An minus 3 is equal to 3 plus 3n over n minus 3, right? That's like saying an minus L. And we would need to prove that this is less than epsilon. This is just kind of my scratch paper in a sense. You could almost call this a lemma, what I'm doing right now, this little bit of algebra. Okay, so that is 3 plus 3n over n minus 3n. Did I get that right? I got a common denominator, so I need to put 3n over n. Oops. And that is equal to, well, it's really easy. I don't even need the absolute value since we're dealing only with positive numbers. I'll go ahead and write that in there. So an minus 3 is equal to this. So what are we going to use for our capital N? capital N. We need that to be less than epsilon. We need 3 over n to be less than epsilon, which could be written as n greater than 3 over epsilon. And that's where we get our capital N, from this little note. Let's make that our capital N. Choose n, a natural number. It does need to be a natural number. This is probably not a natural number. It's positive, but probably it's a decimal. It's not a natural number. Choose n so that capital N is bigger than 3 over epsilon, just like we have written there. And we see that an minus 3 is less than epsilon. If you want to put a justification in parentheses, see note above. So I can write this 2 different ways. The limit as n goes to infinity of an, do I want to write it out, or do I want to just write an? And I'll write it like this. 3 plus 3n over n equals 3. The limit of the sequence. Or 3 plus 3n over n goes to 3 as n goes to infinity. Just 2 different ways of writing the same thing. Again, this is like saying the limit as n goes to infinity of the an goes to capital A. And over here we have an goes to a as n goes to infinity. That's the end of section 1.1.